Hey, sleepers! Tonight, we're taking a gentle journey through our cosmic home. Look up in your mind's eye. You see a velvet black sky, sprinkled with diamond dust stars. A soft, shimmering river of light spills across the canvas, a celestial cloud of impossible beauty. That is our destination. So before you get comfortable, take a moment to like the video and subscribe. We love knowing where our fellow dreamers are listening from. So please feel free to share your city or country and the local time in the comments below. It's a wonderful way to feel connected, all of us under the same vast sky. So close your eyes, take a deep breath, and get ready to drift off as we explore the quiet wonders of the Milky Way. Let us begin with that beautiful name, the Milky Way. It sounds so gentle, so nourishing. The name comes to us from the ancient Greeks. They looked up at that hazy, luminous band stretching across the night sky and imagined it was a splash of divine milk spilled by the goddess Hera. It's a lovely thought, isn't it? A celestial accident creating a river of light for us to gaze upon. The Romans called it the Via Lactea, which means the road of milk. Many cultures have their own beautiful names for it. In parts of East Asia, it is the Silver River, a celestial stream separating two lovers from a famous folktale. In the Kalahari Desert in southern Africa, it is called the backbone of night. What a powerful image that is. The very spine of the darkness, holding the sky together. All of these names, from all of these cultures, speak to a shared human experience. The experience of looking up in awe, feeling both very small and deeply connected to something vast and beautiful. For thousands of years, we told stories about this river of light. We didn't know what it was, but we knew it was special. It was a constant, a guide, a source of wonder. It wasn't until the 1600s that someone really began to figure it out. An Italian astronomer named Galileo Galilei built one of the first telescopes. It was a simple thing, not much more powerful than a good pair of modern binoculars. But when he pointed it at that milky band in the sky, the mystery began to unravel. He saw that the hazy cloud was not a cloud at all. It was made of stars, countless, tiny, faint points of light, packed so closely together that our naked eyes just blur them into a soft glow. It was a breathtaking discovery. He realized we were living inside a colossal structure made of stars. We weren't just looking at something in the sky. We were looking out through the very forest of stars we inhabit. Imagine you are standing in the middle of a very large, very flat forest. The trees are all around you. If you look straight up, you see the sky between the leaves of the trees directly above. But if you look towards the horizon, in any direction, you are looking through a much greater thickness of trees. It seems denser, more crowded. The forest of our galaxy is the same. When we look out of the flat part of our galaxy, we see fewer stars. That's most of the night sky. But when we look along the flat plane, into the thickest part of our stellar forest, we see that dense, beautiful band of light. The Milky Way. We are inside of it. It surrounds us completely. It is our home. So what is this home of ours, really? Our Milky Way is a galaxy. A galaxy is just a giant city of stars, all held together by gravity. Think of gravity as an invisible, gentle string. Every star, every planet, every speck of dust has a little string attached to everything else. When you have billions and billions of stars, all those little strings add up to a very strong pull, keeping everyone together in a cosmic dance. Our city of stars is enormous. It is shaped like a giant, flat disk with a bulge in the middle. a bit like two fried eggs placed back to back. Or perhaps a more peaceful image is a spinning pinwheel on a warm summer evening. A bright, glowing center with beautiful arms spiraling outwards. This is what astronomers call a barred spiral galaxy. The spiral part is easy to imagine, those lovely curving arms. The barred part just means that the very center of our galaxy isn't a perfect ball of stars. It's more of an elongated, bar-shaped clump of stars. From this bar, the great spiral arms begin their graceful curve outwards. Let's take a moment to appreciate the scale of it all. It is a scale that our minds can't truly grasp, but we can try to feel it. Let's talk about light years. A light year is not a measure of time. It is a measure of distance. It is the distance light travels in 1 year. Light is the fastest thing in the universe. It moves so fast that it could circle the Earth more than 7 times in a single second. So a light year is a very, very long way. Our Milky Way Galaxy, from one edge of its spiral disk to the other, is about 100,000 light years across. 100,000. If you could travel at the speed of light, it would still take you 100,000 years to cross our own galaxy. It's a staggering thought. And inside this vast spinning disk, there are stars. So many stars. The current estimate is somewhere between 100 billion and 400 billion stars. For every single person alive on Earth today, there are at least a dozen stars in our galaxy, probably many more. And many of those stars have their own planets. Our sun is just one of them. One star out of hundreds of billions in a quiet, gentle corner of this grand celestial city. Our sun and our little Earth do not live in the busy downtown area of the galaxy. We are out in the suburbs. If the Milky Way is a giant spinning record, we are about halfway from the center to the edge. We live in one of the spiral arms. Or, to be more precise, a smaller, partial arm called the Orion Spur, or the Orion Arm. It's a relatively peaceful neighborhood. This is actually very fortunate for us. The center of the galaxy is a very busy, very energetic place. There are stars packed much more closely together. There is a lot more radiation. It would be a difficult place for life like ours to get a foothold. Here, in our quiet suburban spiral arm, things are calmer. The stars are more spread out. We have the peace and stability needed for life to slowly, patiently evolve over billions of years. We are in a perfect seat to watch the cosmic show. We are far enough from the bright, chaotic center to be safe, but close enough to have a magnificent view of the rest of the galaxy spinning around us. This journey we are on, this gentle orbit around the galactic center, is a long one. Our sun, with Earth and all the other planets in tow, is moving through the galaxy at an incredible speed. About 500,000 miles per hour. Even at that breathtaking speed, it takes us a very long time to complete one full circle around the Milky Way. It takes about 230 million years. This is sometimes called a galactic year or a cosmic year. The last time our solar system was in this exact spot in the galaxy, the first dinosaurs were just beginning to walk the Earth. The time before that, the world was a very different ancient place. It is a humbling and peaceful thought. The galaxy turns with a patience that we can barely comprehend. The dramas of our world, our civilizations, our entire species, unfold in just a fraction of a single galactic year. The great pinwheel turns slowly and majestically, carrying us with it on a silent, endless journey. Let's take a moment to visualize this journey. Close your eyes if you haven't already. Imagine you are floating in space, just above our solar system. You see our sun, a warm golden star. You see the tiny blue marble of Earth and the other planets, all circling it in a slow, graceful ballet. Now begin to pull back, further and further. The planets become tiny specks, then disappear. The sun shrinks, becoming just one star among many. You see other stars drift by. Some are bright blue giants. Some are old, cool red dwarfs. You are now floating in our local stellar neighborhood in the Orion Arm. You can see glowing clouds of gas and dust in the distance. These are nebulae, the birthplaces of new stars. Now pull back even further. The individual stars begin to merge. You start to see the grand structure, the curve of the spiral arm you are in. You see other arms, other rivers of stars swirling in the distance. You pull back more and more until you can see the whole thing. A vast, luminous, spinning island in the blackness of space. The central bar is a bright golden glow. The spiral arms, laced with blue and pink from young stars and glowing gas, swirl around it. This is home. This is our Milky Way, a city of 200 billion suns. Feel the quiet, majestic peace of this image. The silent, slow, beautiful turning. Hold that image in your mind as we continue our exploration. Mapping this incredible city from the inside has been one of the great challenges of astronomy. Remember our analogy of being in a forest? It's hard to know the exact shape of the forest when you're standing among the trees. For a long time, we didn't even know there were spiral arms. The dust and gas between the stars blocked our view. It's like trying to see across a city on a foggy day. You can see the nearby streetlights, but the distant skyscrapers are hidden. But astronomers are clever. They found ways to see through the fog. They learned that some kinds of light, like radio waves and infrared light, can pass right through the cosmic dust. By building telescopes that could see in these kinds of light, they started to piece together the puzzle. They could finally see the distant parts of our galaxy and trace the beautiful shapes of the spiral arms. One of the most important breakthroughs in understanding the size of our universe came from a remarkable woman who worked in the early 1900s. Her name was Henrietta Swan Leavitt. She worked at the Harvard College Observatory as a computer. At that time, computer was a job title for people, mostly women, who performed painstaking calculations and analyzed photographic plates of the stars. It was detailed, often tedious work, and they were paid very little. But Henrietta was exceptionally gifted. She was studying a particular type of star called a Cepheid variable. These stars have a special rhythm. They don't shine with a steady light. They get brighter, then dimmer, then brighter again, in a very regular, predictable pulse, like a cosmic heartbeat. What Henrietta discovered was extraordinary. She found a direct relationship between how fast a star was pulsing and how truly bright it was. The slower the pulse, the brighter the star. This was a monumental discovery. Why was it so important? Imagine you see two streetlights in the distance at night. One looks bright and one looks dim. Is the bright-looking one actually a brighter bulb, or is it just closer to you? You can't tell. This was the problem astronomers had with stars. But Henrietta's discovery changed everything. By measuring the pulse of a Cepheid variable star, astronomers could know its true intrinsic brightness. They could know exactly how bright its bulb was. And once they knew that, they could compare it to how bright it appeared from Earth. The difference told them exactly how far away it was. It was like having a cosmic measuring tape. Henrietta Swan Leavitt gave us the key to measuring the universe. Her work allowed other astronomers, like the famous Edwin Hubble, to measure the distance to other galaxies for the first time, proving that our Milky Way was not the entire universe, but just one island of stars among countless others. It is a beautiful testament to how a quiet, dedicated person, making careful observations, can completely change our understanding of everything. Her work was a quiet revolution, a gentle pulse that unlocked the cosmos. So we are in a spiral arm, a peaceful suburb. Let's take an imaginary journey now, inward, towards the bustling downtown of our galactic city. As we travel closer to the center, the stars become more and more crowded. They are older here too. Many of them are ancient red and yellow stars that have been shining for billions and billions of years. We pass through the dense, glowing central bar. The light is intense. And then, at the very heart of it all, we find the most mysterious resident of our galaxy. At the exact center of the Milky Way, there is a supermassive black hole. Now, the term black hole can sound a little scary. So let's think about it in a calm, simple way. Imagine a perfectly flat, stretched out rubber sheet. This sheet represents space. If you place a small marble on the sheet, it makes a tiny little dip. That's like our Earth or our Sun. It has gravity. It bends the space around it just a little bit. Now, imagine taking a very, very heavy bowling ball and placing it in the middle of that same rubber sheet. It would create a deep, steep well in the fabric of space. That is a black hole. It is an object with so much mass, so much stuff, packed into such a tiny space that its gravity creates an incredibly deep well. The gravity is so strong that once something gets too close and falls in, it can never get out. Not even light, the fastest thing there is, can escape. That's why it's called black. It doesn't produce any light of its own. The supermassive black hole at the center of our galaxy has a name. It is called Sagittarius A*, pronounced Sagittarius A*. It has the mass of 4 million suns, all crushed down into a single invisible point. But here is the important and reassuring thing. Sagittarius A* is not a cosmic vacuum cleaner. It is not sucking in the galaxy. Its intense gravity only dominates a very small area right at the galactic center. We are about 26,000 light years away from it. We are perfectly safe, orbiting it from a vast, vast distance, just as the Earth orbits the Sun from a safe distance. It is the quiet, heavy anchor at the center of our spinning galactic home. For a long time, Sagittarius A* was just a theory. We couldn't see it, of course. So how did we know it was there? This is another wonderful story of scientific patience and ingenuity. Astronomers, including a brilliant scientist named Andrea Ghez, spent decades watching the very center of the galaxy with powerful infrared telescopes. They couldn't see the black hole itself, but they could see the stars orbiting it. They meticulously tracked the paths of these stars, year after year. What they saw was astonishing. These stars were whipping around an invisible point at incredible speeds, some moving at millions of miles per hour. They were like planets in a frantic, high-speed dance around an unseen sun. By plotting their orbits, Dr. Ghez and her team could calculate exactly how massive the unseen object at the center must be to hold onto those stars so tightly. The answer was clear. There had to be an object with a mass of 4 million suns packed into a tiny space. It was the definitive proof that a supermassive black hole resides at the heart of our Milky Way. For her incredible work, Andrea Ghez shared the Nobel Prize in Physics in 2020. Her dedication, watching those stars dance for decades, gave us a clear picture of the mysterious heart of our home. Now, let's journey outwards from the center, back to the beautiful spiral arms. We live in the Orion Spur, but there are much larger, grander arms. The major arms of the Milky Way have names like the Perseus arm, the Scutum Centaurus arm, and the Norma arm. These arms are not solid structures, like the spokes of a wheel. This is a common misconception. A star isn't born in an arm and then stay in that arm forever as it rotates. The reality is much more fluid and fascinating. The spiral arms are more like a traffic jam on a cosmic highway. Imagine cars moving along a highway. If there is a slow-moving truck up ahead, the cars will bunch up behind it. The jam itself stays in one place, but individual cars are constantly entering it, slowing down, and then exiting it and speeding up again. The spiral arms are like that. They are what we call density waves. They are areas where the gravity is a little bit stronger, causing stars, gas, and dust to bunch up as they pass through. So our sun and all the stars are orbiting the galactic center, and as we do, we sometimes pass through these denser spiral arms. The arms themselves move, but at a different speed than the stars. When a cloud of gas and dust enters a spiral arm, the density wave squeezes it. This compression is the trigger for new stars to be born. That's why the spiral arms are the stellar nurseries of our galaxy. They are filled with beautiful glowing nebulae, clouds of hydrogen gas that are lit up from within by the hot, bright newborn stars. The most famous young stars are massive and blue. They burn through their fuel very quickly and live short, brilliant lives. Because they don't live long enough to travel far, we almost always find them inside the spiral arms where they were born. This is why the spiral arms of our galaxy and other galaxies we see are often tinged with a beautiful blue light. They are the bright, sparkling evidence of creation happening right now. It is a slow, cosmic process, a gentle squeeze that ignites a star. And what about the space between the stars? We often think of space as being empty, a perfect vacuum. But that's not quite true. The space between the stars in our galaxy is filled with something called the interstellar medium. It is a very, very thin soup of gas, mostly hydrogen, and tiny particles of dust. The dust is not like the dust in your home. It's more like very fine smoke or soot. These tiny grains are made of carbon, silicon, and other elements. Even though this medium is incredibly thin, far thinner than any vacuum we can create on Earth, it adds up over the vast distances of space. This dust has a very interesting effect. It blocks and scatters starlight. Specifically, it scatters blue light more than red light. This is the very same reason that our sky is blue and our sunsets are red. The Earth's atmosphere scatters the sun's blue light, filling the sky with it. At sunset, the sunlight has to pass through much more atmosphere to reach our eyes, so most of the blue light is scattered away, leaving the beautiful reds and oranges. The interstellar dust does the same thing to starlight. When we look at a distant star through a lot of dust, it appears redder and dimmer than it really is. This is called interstellar reddening. It was another puzzle astronomers had to solve to map the galaxy accurately. But this gas and dust is more than just a cosmic fog that gets in the way. It is the very essence of the galaxy's life cycle. It is the raw material from which new stars and planets are made. And where did this material come from? It came from older stars. When stars, especially large ones, reach the end of their lives, they don't just fade away. They can explode in a spectacular event called a supernova, or gently puff off their outer layers to form a beautiful planetary nebula. In these final acts, they release all the heavier elements they have forged in their cores throughout their lives. Elements like carbon, oxygen, iron, and silicon. These elements then mix with the hydrogen gas of the interstellar medium, enriching it. This enriched gas and dust then collapses to form the next generation of stars, and crucially, the planets that orbit them. This is one of the most profound and beautiful connections in all of science. The iron in your blood, the calcium in your bones, the carbon that forms the basis of all life as we know it, none of these were created at the beginning of the universe. They were forged in the fiery hearts of stars that lived and died long before our sun was born. We are, in the most literal sense, made of star stuff. The universe is not just something we are in, we are of it. The atoms that make up your body have been on an incredible journey. They were once part of a giant cloud of gas, then cooked in the core of a massive star. They were flung across the galaxy in a supernova explosion, drifted for millions of years through the interstellar medium. And then, 4.5 billion years ago, they came together in a new cloud that collapsed to form our sun, our Earth, and eventually you. Take a slow, deep breath. The oxygen you just inhaled was likely forged in a star. It's a deeply connecting thought. We are stardust, contemplating the stars. Now let's pull our perspective back once more. We have explored the disk of our galaxy, the central bulge, the spiral arms, but there is more. Surrounding the entire flat disk of the Milky Way is a vast, spherical region called the galactic halo. It is like a faint, ghostly sphere of stars enveloping the main galaxy. The halo is the old folks' home of the galaxy. It is sparsely populated with very ancient stars and groups of stars called globular clusters. A globular cluster is a tight, spherical ball of hundreds of thousands of old stars, all bound together by gravity. They are like ancient, glittering snow globes, orbiting high above and below the main galactic disk. They contain some of the very first stars that ever formed in the Milky Way over 12 billion years ago. They are cosmic fossils, giving us clues about what our galaxy was like in its infancy. But the halo contains another, much deeper mystery. The stars and gas we can see, all the luminous matter, only make up a small fraction of the galaxy's total mass. We know this because of the way our galaxy rotates. If all the mass was in the stars we can see, then stars on the outer edge of the galaxy should be moving much more slowly than stars closer to the center, just like the outer planets in our solar system, like Neptune, orbit the sun much more slowly than the inner planets, like Mercury. But that is not what we observe. When we look at the outer edges of the Milky Way, we find that the stars are moving just as fast as the stars further in. They are moving far too fast. There is no way the gravity of the visible stars could hold onto them. They should be flying off into intergalactic space. The fact that they aren't means there must be a huge amount of extra mass, extra gravity, that we cannot see. This invisible substance is called dark matter. It's called dark simply because it doesn't seem to interact with light in any way. It doesn't shine, it doesn't reflect, it doesn't absorb. It is completely invisible to all of our telescopes. We only know it's there because we can feel its gravity. The pioneering work on this was done by another brilliant female astronomer, Vera Rubin. In the 1970s, she and her colleague Kent Ford made incredibly precise measurements of the rotation of other spiral galaxies. They expected to see the rotation speeds drop off at the edges, but in galaxy after galaxy, they found the same strange thing. The edges were spinning just as fast as the inner parts. Vera Rubin's meticulous work provided some of the most compelling evidence for the existence of dark matter. At first, her results were met with a lot of skepticism, but the evidence was undeniable, and she patiently and persistently defended her findings. Today, dark matter is a cornerstone of modern cosmology. So what is this dark matter? The honest answer is, we don't know. It is one of the biggest mysteries in all of science. But we can imagine it. Think of our galaxy, the bright spiral of stars, as the foam on top of a latte. The foam is what you see, but the vast majority of the drink, the coffee itself, is underneath. Dark matter is like the coffee. It provides the bulk of the mass and the gravitational structure. It forms a huge invisible halo, and our visible galaxy is just the luminous stuff nestled in the very center of it. It's like an invisible scaffolding that holds our entire galactic city together. It is a humbling reminder that what we can see of the universe is only a tiny fraction of what is actually there. Most of our universe is quiet, invisible, and mysterious. Our Milky Way is not alone in the universe. It is part of a small cluster of galaxies called the Local Group. It's a cozy little cosmic neighborhood. There are about 50 galaxies in our group, most of them small dwarf galaxies. But there are 3 large spiral galaxies: our Milky Way, the Andromeda Galaxy, and the smaller Triangulum Galaxy. The Andromeda Galaxy is our closest large neighbor. It is about 2.5 million light-years away. That might sound incredibly far, but in cosmic terms, it's just next door. On a very clear, dark night, away from city lights, you can actually see the Andromeda Galaxy with your naked eye. It looks like a small, faint, fuzzy smudge in the sky. What you are seeing when you look at that smudge is the combined light of 1 trillion stars. And that light has been traveling through space for 2.5 million years to reach your eye. You are looking 2.5 million years into the past. Andromeda is a little bigger than the Milky Way, and it is heading right for us. Or rather, we are heading right for each other. Pulled together by our mutual gravity, our 2 galaxies are on a collision course. But again, this is not something to be anxious about. This is a cosmic event of immense slowness and grace. The collision will begin in about 4.5 billion years. It will not be a violent crash. A galactic collision is more like 2 clouds of smoke slowly merging. Stars inside galaxies are incredibly far apart. The chances of any 2 stars actually hitting each other are almost 0. Instead, the 2 galaxies will pass through each other, their stars mixing like 2 swarms of bees. Gravity will distort them, pulling out long streams of stars and gas. They will separate, then be pulled back together again, and after several passes over hundreds of millions of years, they will finally settle down and merge into one single giant new galaxy. Some astronomers have already given this future galaxy a name: Milkomeda. Our distant descendants, if any exist, will live in a very different-looking home. They might look up at a night sky filled with the blended stars of 2 galaxies, a beautiful testament to a cosmic dance that began billions of years before. It is a peaceful, long-term perspective. The universe is not static. It is constantly, slowly, gracefully changing. As we near the end of our journey tonight, let's reflect on how we have learned all of this. It is a story of human curiosity. For centuries, we could only look at the sky with our own eyes. Then came Galileo's telescope. Over the years, we built bigger and better telescopes, placing them on high mountaintops to get above the blurring effects of our atmosphere. Then, we began to send telescopes into space itself. Telescopes like the Hubble Space Telescope, which has given us so many breathtaking images of the cosmos. We built telescopes that can see in different kinds of light beyond the visible rainbow. Radio telescopes, looking like giant satellite dishes, listen to the faint radio whispers from distant gas clouds. Infrared telescopes, like the James Webb Space Telescope, can peer through the thickest dust clouds to see stars being born. X-ray telescopes can see the intensely hot gas swirling around black holes. And in recent years, an incredible mission called Gaia, launched by the European Space Agency, has been undertaking an extraordinary task. It is creating a precise three-dimensional map of our galaxy. It has been meticulously measuring the positions, distances, and movements of over 1 billion stars. 1 billion. It is a galactic census of unprecedented scale and precision. Thanks to Gaia, we are discovering the history of our galaxy, written in the motions of its stars. We can see streams of stars that are the remnants of smaller galaxies the Milky Way has swallowed in its past. We can trace the true shapes of the spiral arms. We are building a detailed picture of our home city, block by block, star by star. It is the work of thousands of scientists from all over the world, working together over many decades, all driven by that same simple, fundamental wonder that our ancestors felt when they looked up at that river of light in the night sky. So, here we are, drifting peacefully in a quiet arm of a vast, spinning city of stars. This city is ancient, over 13 billion years old, almost as old as the universe itself. It is immense, 100,000 light years across. It is filled with hundreds of billions of suns, and likely trillions of planets. It has a mysterious, quiet heart. It has beautiful, creative arms where new stars are being born right now. It is surrounded by a ghostly halo of ancient stars and a vast, invisible web of dark matter. It is on a slow, graceful journey, destined to merge with its nearest neighbor in the far, distant future. And within this vastness, on a small, rocky planet orbiting an ordinary yellow star, we exist. We are a way for the cosmos to know itself. The stardust has woken up. It has built telescopes and written equations. It has told stories and composed music about the night sky. And tonight, it is lying in bed, listening to a gentle voice describe its own grand, cosmic home. Feel the weight of your body, a small collection of stardust resting comfortably. Feel the slow, rhythmic pattern of your breath, a simple, peaceful anchor in the vastness of time and space. You are a part of this incredible story. You are not separate from the Milky Way. You are the Milky Way. You are a thinking, feeling, dreaming part of this universe, looking out and wondering about the rest of itself. There is no need to feel small or insignificant. Instead, feel a sense of belonging, a deep, quiet connection to the grand, silent, beautiful dance of the cosmos. The galaxy will continue its slow, majestic turn long after we are gone, and it was turning long before we arrived. But for this brief, precious moment, we are here. We are aware, and we can appreciate the profound peace and beauty of our place in the universe. Sleep well in our quiet corner of this magnificent starry home.